Alright, so welcome everyone to today's live stream. I will be explaining to you vectors in today's class. So, before we before we waste any more time, let's dive in to what vectors are. And this is the lesson plan for today. So, in today's class, we'll be discussing vectors, component of vectors, and additional vectors. This is one of the most fundamental and basic topic of your JEE career, as you will need vectors in every part of life, and especially in JEE mains and JEE advanced specifically, but because these concepts will be applicable in every topic of physics, be it 11th or be it 12th. So you have to keep this in mind that this concept will build the foundation of your IIT career. So let's begin, shall we? So scalar. Now, what do we have here? We have scalar. So what is scalar? Let's think about this for a minute. Okay, let me just change my ink color. Yep, yeah. So what is scalar? In order to define scalar, we need to know what do we mean by scalar. So there exist two quantities in nature. Let me just write it down so that it's easier for you to understand. There exist two quantities 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 in nature, and those are defined as scalar and vector, right? So we will be discussing what scalar and vector is. But before that, before discussing what vector is, let's discuss what scalar is, because up till now we have only seen scalar quantities in mathematics, and basically mathematics only. Because in physics, if you remember correctly, in ninth standard you might have come across a term called velocity and acceleration. Those are vector quantities, right? So let's not let's just build a foundation upon what we know already, that is scalar. So what is scalar? Scalar, so let's define scalar. Let me just write it down by point, right? So it is quantity which has only magnitude. It is a quantity which has only magnitude magnitude right? Okay, let me just, how about if I erase this, because this might not be visible to some of the people in the stream. All right, so we have, it has only magnitude. Now, what do we mean by this? What do we mean by this? For example, I told you, you asked me to go to the market, and I said that what should I need to, what do I need to bring from the market? You ask you tell me that you need to bring 5 kg tomatoes, 5 kg tomatoes, right? But so luckily I don't know what kg is. So I will ask you, how many tomatoes should I bring? You will tell me 15, or you will tell me 20 or 25. So you would give me an abstract number. That is, just bring 25 tomatoes, nothing else. Nothing else matters. So what matters is the number which I give you. For example, in case of tomatoes, the number 25 matters. 25 matters, right? So, the number, what's the thing which matters only is the number. Okay, right, sorry. Let me just write it down. Pen, yeah. The thing which matters is number. And it can be represented in numbers only. Can be represented in numbers only. In numbers only, right? So, as I explained earlier, it only needs a number to represent itself, nothing too fancy. So if you have any doubt regarding this, please ask me at any point in the stream, because I'm there to teach you and help you solve your doubts. So, and also to keep this in mind, that whatever I write on the screen is extremely important, and you should note it down, because these are the points which I have made personally. which I believe that are essential in order to build a great foundation, in order to build a strong foundation, right? So let's come to the third point. Third point is it can be added, it can be added, subtracted, sub, subtracted, and multiplied normally, right? Right. So this thing might come to you as something like a natural instinct. So you like, yeah, this thing should be, everything should be able to, should be added, subtracted, or multiplied. Like there's no other way than multiplying that, except normally. But in case of vectors, there's something changes. There are some complications which we will deal with in the, in upcoming topics. Basically in this chapter, in this chapter only. So let's not waste the time on this, because you will learn about this, and I think in this class only after 20 or 30 minutes. So let's now I think this is it for scalars. So let's jump into vectors. What are vectors? What are vectors, right? So let's dive further. My favorite topic, vector, has begun. So what are vector? So vector are the quantities which have, it is a quantity which have magnitude and direction. Keep this in mind. It is the quantity with both magnitude and direction. With both with both magnitude and direction. So this is the basic definition, right? And this definition is quite important, because as we move forward, we will learn about why magnitude and direction are important. Because in order to define something, we need a direction sometimes. Like for example, I tell you to go, to go 5 kilometers. Like I just tell you to go 5 kilometers, and you will ask me, 5 kilometers where? Where should I go? What you will basically ask me the direction of my statement. Like that is, uh, for example, if I'm in Delhi, I would ask you to go like 5 kilometers towards east or 5 kilometers towards west. You'd ask me that, right? You need direction. So this is just like vector. You need direction also to specify what your statement means, right? You need both magnitude and direction, right? So geometrically, vectors are represented by a directed line segment. So this is a directed line segment. Keep this in mind. This is not a line. This is the direct. Let me see. Directed line segment. Line segment. So geometrically, it is represented by a directed line segment. Why a line segment? I will tell you. Because the length of the arrow represented by the magnitude is represented by the magnitude, right? So this length of the vector is just magnitude. So if you see a longer vector, if you see a longer vector, then it means that it has a greater magnitude than a shorter one. So this is basically it. So length of the arrow represents, write it down, because this is quite important. As when you write something down, it becomes imprinted in your memory. You will never forget it if you write it down. That's what my father used to tell me. Used to tell me that if you have something, just write it down. You will never forget it. And this is a very useful advice, which I would like to give you. So length of the arrow, because this is the arrow, right? It's the arrow is the magnitude of the vector, is the magnitude of the vector, right? Pretty straightforward till now. So and of course the direction represents the direction in which the direction is, what is pointed. If it's pointed towards right, then it is going in the right direction. going is pointing towards east or whatever. You understand what I'm saying, right? If the direction is basically the direction, it's pretty straightforward till this point. So let's move on towards the next topic, which is parallel vectors, right? Let me just because this is a very important topic. This this basically tells you the properties of vector. This particularly tells you a property of vector which will be used in every concept. Basically, this will tell you about translatability of vectors. So that means the vectors can translate from one position to another. So let's move on and see that what do we mean by this. So the definition is that two or more vectors, two or more parallel arrows having the same length and direction in the same having the same length and pointing in the same direction represent the same vector. That means two arrows, two or more parallel arrows having the same length and pointing in the same direction of right, they would be the same vector. For example, let me just write it down. Two or more parallel arrows pointing sorry, before pointing in the same direction, pointing in the same direction. Good evening, Nishan. Good evening. Pointing in the same direction. Two or more parallel arrows pointing in the same direction and having the same length, having the same length represents the same vector, right? Represents the same vector. So this is the definition which about parallel vectors, which you need to keep in mind because I'm writing this definition because I want you to keep this in mind and I want you to write it down as we proceed because this is quite important. And let's see what do we mean by this. Two or more parallel arrows. So that we have arrows, two or more parallel arrows. We have arrows like this, right? These arrows are parallel. Two or more parallel arrows pointing in the same direction. So we need to point them in the same direction. That is the necessary requirement. So of course this arrow will not point over there. This arrow will point over here, right? This is the arrow. This arrow will point over here. And having the same length, they should have the same length too. Pretty interesting. They should have the same length too. So let's see. Pen. Yeah. So they should have the same length. Represent the same vector. Okay. So this thing is quite interesting. Suppose this is the vector A, and they're saying that this arrow also represents the vector A. You'd ask me, how is that possible? Well, it is possible because a vector pointing in a direction, and having the same magnitude basically represents the same thing. For example, I tell you go 5 kilometers east, right? And if like consider that I'm standing on the origin, if I tell you go 5 kilometers east, and I also tell you go 5 kilometers right, right? Both those are basically the same thing said in a different way. So basically, these are this is also the same thing said in a different way. Now, what do we get after? What do we get from this? What do we get from this? This tells us in a single sentence. This tells us that vectors can be translated parallelly. That means vectors can be translated translated parallelly parallel parallelly. So this statement is quite important, right? This is quite okay. All right, now I again made a mistake. Okay, sorry. This statement is quite important because if you know that vectors can be translated parallelly, that means you can just drag a vector anywhere. Now remember, when I say parallelly, I mean that suppose this is a vector called, this is something, this is a vector A, right? This is a vector uh, A, and you can translate it by dragging it over here. This will be also called A, but you cannot drag it over here. Let's say here, right? You cannot drag it over here. Uh, you cannot make this something like this, right? Of course, it's parallel, but it's also, it has also, you know, moved towards, moved in a forward direction, moved in an upward direction. That is not possible. So this is wrong. This is correct. So that means the vector can be translated parallelly. This is quite important in understanding components, in understanding addition of vector, and understanding basically everything about vectors. So what is meant by translated parallelly? Translated parallelly means, let me just explain it again. So translated parallelly means a vector can be translated parallelly. For example, uh, have you seen parallel lines, right? You must have seen parallel lines. Parallel lines are like this, right? Okay. Let me just, all right, that was covering my face. All right. Let me just remove this so that I will be able to explain it to you in a more clear way. Uh, yeah, yeah. So let's jump into this topic because this is quite necessary. This is very important for you to understand. What do we mean by parallel? So have you seen parallel lines? Like parallel lines are like this, right? Straightforward. So parallel lines, these lines are not parallel lines. These lines are not parallel lines, but only these lines are parallel lines because they have same distance. Same with vectors. Same with vectors. Suppose a vector is like A, right? And if you want to translate it, you can only shift it in that manner only. For example, if vector is pointing like this, you can shift it like this. You cannot shift it like this. You can only shift it like this. That's what I mean when I say parallel vectors. That means this can be translated into, this can be translated into, this can be translated into, and this can be translated into, this can be translated into something like this, but not into something like this, but not into something like this. For example, uh, yeah, but not into something like this, because we cannot change the direction of the vector. Direction of the vector should be pointing in the same direction as the earlier vector pointed at. This cannot be, this is wrong. We cannot translate it in this way. For example, consider this pen as a vector, right? So this pen can only be translated in this manner. For example, it can go here, here, right? Here, maybe here, but not like this. This pen cannot be like this. This pen should be, in a parallel way. For example, this is possible, but this is not possible with vectors, because as you change the direction, you are changing the vector, because a vector is defined by both direction and magnitude. So direction is also important. That's what we mean in parallel vectors. You cannot change the direction of vectors. That is the most necessary, the most necessary condition. If you change the direction, you are changing the vector completely. For example, we have, let's say, 5 kilometers east, right? This is a displacement vector. We have 5 kilometers east. You say, if you change the direction, if you make it like 5 kilometers north, then it's a completely different vector. 5 kilometers north is not equal to 5 kilometers east, right? You will reach a completely different point. For example, if you are from the, if you are from, let's see 50 kilometers, right? 50 kilometers east and 50 kilometers north. If you're in Delhi, if you reach 50 kilometers east, you will probably, you reach something near Meerut or something like that. I don't remember correctly. So yeah, if you go to those 50 kilometers east, then you would reach Meerut. If you go 50 kilometers north, you will reach Sonipat. Completely different places and completely different vectors. Makes sense, right? So that's what we mean when we say that parallel vectors. When we say vectors can be translated parallelly, that means only parallel translation is possible. If you have any questions regarding this, please ask me. If there's any specific doubts. All right, this is very important topic and also quite interesting one, as this will be used in upcoming you know in our upcoming topics. So let's move on to the next slide. That is multiplication of vectors. All right, let's see. Multiplication of vectors, right? Consider a vector A multiplied by a scalar k. So we have A as a vector, right? By the way, vector are represented by this A, all right, by a line on their top of their head. It can also be represented by this two, an arrow. Okay, I'm sorry. I will try to talk slowly. Sorry. Okay, that's an honest review. So consider okay. If you have anything, if you need to ask anything, I'll repeat my words if there's anything which you have missed by then. So now I will talk in a more slower pace, right? So consider there is a vector called A, and there is a scalar k. So scalar is just a number. It is just a quantity, scalar k. Now we need to talk about the multiplication. So consider A is multiplied by k. So we have something like ka, right? Multiplication yields this. Multiplication, multiplication, multiplication yields. Multiplication yields ka. That's pretty self-explanatory. So let's jump into what we are dealing with k. What we are dealing with here. So if k is greater than 0, right? If k is greater than 0, that means this whole quantity will be greater than 0, right? That means ka, ka, this whole thing will be greater than 0, right? What do we mean by that? That means the direction of the vector does not change. That means direction of vector does not change. Of vector does not change. Change. Okay. Direction of vector does not change. If k is greater than 0, that means ka is greater than 0. That means the direction of vector does not change. That means that direction. So basically, the sign of vector is determined by direction, right? If the sign does not change, that means the direction does not change. And if k is less than 0, again by this logic, if k is less than 0, that means ka is less than 0, right? That means direction of vector has changed. Direction has changed. This is pretty self-explanatory at this moment. So the what will be the magnitude of this? Magnitude after a multiplication magnitude will be just Ka. Will be the magnitude. 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 Right. So this will be basically multiplication of vector. If you need to write down anything, just write it down, because this is necessary when you understand scalar multiplication, scalar product, dot product, and this will come in handy in next topics. uh, Direction of, so what we have provided is a is vector, k is scalar, multiplication of a vector yields ka. If k is greater than 0, that means ka is greater than 0, that means the direction of vector does not change. If k is less than 0, that means ka is less than 0, that means the direction has changed. So ka basically is magnitude. If we apply modulus to the vector, we will get the magnitude. So this is pretty straightforward till this point. I believe you have noted this till now. So let's move forward towards unit vectors. Unit vectors. So this is this is interesting topic, because children, when we are studying for IIT, we do not focus our mind on this, because this topic seems like a very easy one. It is an easy one, but it is also one of the most necessary topics in order to understand. This is also one of the most necessary topic in order to understand what we mean, what we do in vectors, in order to understand components, in order to understand addition of vectors. So we need to define what unit vector is. So a vector of whose magnitude is 1 is called unit vector. Let me just write it down because what I'm writing down is quite necessary. Vector. Okay, sorry. Or sorry, my ink spill. It looks like that. Uh, yeah, vector, vector, whose magnitude, whose magnitude, magnitude is 1 is called unit vector. Unit vector. Right? If there's anything that you need to ask me that you do not understand, if I'm speaking to first or anything, just write in the just write in the chat section. I will try to rectify your doubts on anything. So unit vector is like this is unit vector. So why do we need to define unit vector? It's just like this. Suppose this is x-axis, right? And this is y-axis, and there's a vector of magnitude 1. Magnitude 1. This is a vector of magnitude 1. Yeah, 1 basically. So why do we need to define it, right? It's necessary, right? It is necessary to define it. Why? Because if we define it correctly, then we can represent any vector. We can represent any vector as a multiple of unit vector. For example, we have, let's say, 5, 5. Let's say this is a vector called 5. This is a vector called A, whose magnitude is 5, right? Which is pointing in x-axis. It is pointing in x-axis direction, right? Its magnitude is mag is 5, right? So we can write it as 5 into unit vector along x-axis. Now it makes a little bit of sense because we can represent this vector as a multiple of unit vectors along x-axis, or maybe even y-axis, or maybe even z-axis. That is, if we are talking in 3D, like in three dimension, this is also a thing called z-axis. So let's write it. Let's write some definition. A unit vector along. So a unit vector along x-axis is I cap, right? This is I cap. This is standard convention. So we will say that if there is a unit vector along x-axis, this will be called I cap. This is the standard convention. I'm gonna show you where it is used in just a minute. Just let me write down the definition, the basic definition. A unit vector along x-axis is I cap. Unit, again, same thing, unit vector along y-axis axis is j cap, right? Y-axis is x-axis I cap, y-axis j cap, and if you move forward, then we have z-axis, which is of course k cap, like as we can see from what's happening. So let's just let's just write it down. Why like my father told me that in writing, don't be lazy, because if a student is lazy, then he will not be able to achieve anything. So let's become a student. Let's become a dedicated student, a shishya, as per Hindu teaching. So a unit vector along z-axis is k cap, right? We have this. So we have written everything. We have this. Suppose there is a unit vector along x-axis. We will just write it as I cap. I cap. Let me just remove that because it's getting quite hodgepodge over there. So one more time, explain this. Okay. So there is a vector. So unit vector is defined as a vector whose magnitude is 1, right? So it can be anything. It can be this, like this is a vector called A. Its magnitude is 1. That means A magnitude is equal to 1. It is called unit vector. It is just a definition of unit vector. This is defined as unit vector, right? This is A. So, we have something like this. If there is a vector, like we have some rules. These are the standard convention, right? For example, you have weight, right? A standard weight of of 1,000 grams is called 1 kg, something like this. This is called unit vector. A vector whose magnitude is 1 is called unit vector. That's just a standard definition. All right. So we have vector A whose magnitude is equal to 1. So this is called unit vector. So this will also be defined as unit vector. Now, why do we need unit vector? So the question arises: why do we need unit vector? We need unit vector in order to define many vectors. So, example, if a vector is in order to define many vectors as a multiple of unit vector. For example, I say that there is a vector called there's a vector there's a vector called B, right? B, whose magnitude is 7, like whose magnitude is 7, and it is pointing in x-axis, right? So we can say that b is equal to, let me just erase it. So we can say that b is equal to right, b is equal to 7 into unit vector along x-axis. That means 7 into 1, magnitude of unit vector is 1, but we will have direction along with that. So 7 into unit vector along x-axis. That what do we mean by this? What do we mean by this? We mean that b is just 7 multiplied by unit vector. And what is the unit vector along x-axis? It is I cap. 7 into I cap. So it is just 7 I cap, right? And when we see, so okay, like, so when we see, when we move forward, we will have many vectors which are like something like this: 5 I cap plus 6 j cap, something like this, because they will be combination of two unit vectors, right? So unit vector basically tells you in which direction it is pointing, in which direction a vector is pointing. For example, a vector is as we move forward, you will understand what you will mean. Where do unit vectors come into play, and where do we use them? Look at this. So unit vector along y-axis is j cap, along z-axis is k cap. This is defined. So don't waste your time on this. Because it is just defined. Don't think about derivation or about this, because this is just standard convention. We say that a vector whose magnitude is 1, and if it is pointing in x-axis, is just I cap, just that. And vector whose magnitude is 1 and it is pointing towards y-axis is called j cap. 1, its magnitude is 1, is called j cap, right? Its magnitude is 1 and it is pointing towards x-axis, it is called I cap. Just that, nothing to worry about here. If there's if there's anything which needs to be explained further, I will explain it in next slide, in which we discuss about components, right? Let me just move to the next slide. If there is anything additional you want to ask me, then you can just type it out in the chat box. It is very, very interesting, and I would be happy to answer it. So let's jump into components and see, where do we use unit vectors? Why do we need unit vectors? And why do we need to define unit vectors? Right? That is the main question, which comes into our mind when we study about unit vector. So what is components? Right? Suppose there is a vector. Suppose this is x-axis. Right? This is x. Okay. Eraser. Suppose there is a vector called, this is x-axis, right? And this is y-axis. Suppose there is a vector called from origin. Basically, it can be any point, but let's just say origin for convenience. A vector. It is a vector called A, and it is making an angle theta. Uh, this is making an angle theta with the x-axis, right? Now, what do we mean by components? What do we mean by components? Basically, we split the vector A in two parts. Let's just write it down correctly. We, all right, Crazy Narendra has understood that. That's perfect. We split the vector A in two parts. Two parts, right? So we split the vector A in two parts. That means, and what are those parts, right? So we split the vector two parts so that one part is parallel to x-axis, is parallel to x-axis, and yeah, and the and other part is, okay, parallel to y-axis. Yes, yes, we finally have written the definition. So writing the definition is the most difficult part, because it's just pure writing. You cannot explain anything while writing definition. So that's just it. So basically, let's just talk about what we mean by this. We split the vector into two parts, right? We say that vector A is made up of two vectors. For example, it is made up of two vectors, which are basically vector along y-axis and vector along x-axis. So that's basically it. So how do we define that? How do we define theta? How do we define theta? Right? So let's just see. So what do you mean by theta? Right? What do we mean by theta? Suppose this is a triangle. This is a triangle, right? This is a triangle. Uh, 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 yeah. And in a triangle, as you have studied in class 10 trigonometry, what will be this called? What will this be called in a perpendicular triangle? Let's just say this angle is 90-degree, right? This will be called perpendicular. This will be called base, and this will be called hypotenuse. Pretty straightforward, just pure class 10 trigonometry, nothing else. So let's move further and let's define. What do we mean by that? What do we mean by this? Why do we have painted a triangle? So let's see what is cos theta. What is cos theta? Let's forget everything. Let's jump back into class 10th and let's see what is cos theta. Cos theta is based upon hypotenuse, right? B upon h, or base upon hypotenuse. Hypotenuse, base. Oh God, am I writing? Base upon hypotenuse. Okay, base upon hypotenuse. This is cos theta. And now tell me. Then b base. Let's just transfer h over here. Then base will be equal to h cos theta. Right? Pretty straightforward. So what is h? H is our vector a. H is our vector a. That means a cos theta. Cos theta. A pretty interesting result. That means a cos theta is equal to base. So let's just highlight it. Right. And let's remove this part of what I have written. I hope you have written this part, right? You have written this part, because I am going to erase it. And let's just erase it, because if you need to write it down, just go back in this just rewind it basically 5 minutes back, and you will just see what I've written. So in order to explain it to you, I need to erase it. Sorry, my dear students. Okay. Come on, erase it. Okay. Yeah. So what do we have here? What do we have here? What do we have here? So now let's define sine theta from our knowledge in 10th. From 10th class, sine theta is perpendicular upon hypotenuse. Perpendicular Perpendicular. This name, brings back some memories. Perpendicular, perpendicular upon hypotenuse. If you are hypotenuse, if you are, somewhat connected, then you might have seen this name as the name of a person, a very interesting person in a certain movie, Perpendicular. But let's not talk about that. Let's jump. Let's see what we mean by this. P upon H, right? That's what we mean. So what is perpendicular and what is P? P equal to H sine theta. Hmm? I just transferred H over here. I just transferred H over here, towards there, and pretty straightforward. P is equal to H sine theta. That means, and what is H? H is vector A. So that is A sine theta equal to P. So now these are very important results. These are very important results. Keep this in mind. Right? Write it down, take a screenshot, or do whatever. These are very important results. What do we get by this? What do we get by this? That means we get that P is equal to A sine theta and B equal to A cos theta. Right? We have split it. We have split this vector into two parts. We don't need A. We just need A sine theta. And we have, sorry, I forgot to write A. Yeah, we have A cos theta. We just need that. It is along x-axis, it is along y-axis, and supposedly, we know Pythagoras theorem. Perpendicular square plus base square should be equal to hypotenuse square, right? So let's just do that. Let's just do that. A square. Okay, let me just. Sorry. Uh, yeah, let's just do that. Let's just verify our findings. So what is h square equal to b square plus p square? As per Pythagoras theorem, right? Pytha, my man Pythagoras theorem, Pythagoras theorem, right? It is like, it should be like, natural to you, because Pythagoras theorem we have studied it in 7th class. It's like too long ago at this point, but it's still the basics, right? So b square plus p square. What is b? B equals a square cos square theta plus a square sine square theta. Now we take a square common. We have cos square theta plus sine square theta, which is of course equal to 1. Equal to 1. That translates it into a square. H square equals a square, and that is what we should have got earlier. H square equal to a square. So we have divided our vectors. Let me just erase the proof. Proof is just straightforward. You don't need to memorize it. You just need to add these through Pythagoras addition, Pythagoras theorem. Proof is pretty straightforward. You don't need anything to memorize it. So I'm gonna remove it. It is given in NCERT if I'm not wrong. But I'm gonna tell you about you won't need this proof, because what I'm going to tell you in the next slide is far more interesting than this proof. Let me just try to remove this proof, because for you, in order for you to understand, a small formula, a small trick, a small technique to how to remember this. Think about this way. Think about it this way. If vector is making an angle theta with anything, then component along that will be vector into cos theta, and component perpendicular to that will be sine theta, vector sine theta. So perpendicular component is equal to vector sine theta vector. This is very important result. Write it down, right? This is quite, like, this is one of the most important result which you could get from this component theorem. Perpendicular component sine theta, vector into sine theta, vector into sine theta, and parallel. Sorry, okay. Oh God, I have written something. Yeah, blasphemy. That was called blasphemy, because I should not have written perpendicular sine. And parallel component is vector into cos theta. Yeah, vector into cos theta. Right? So if it is making an angle theta with an axis, the parallel component to that axis, the parallel component to that axis will be vector into cos theta, and the perpendicular component to that axis will be vector into sin theta. Right? Keep this in mind. Parallel component to the axis, perpendicular component to the axis. And what is the axis here? X-axis. All right. So this is very interesting result, and this is also something which we should keep in mind, because this result will help us in solving the next problem which we have. Basically, not a problem, but a result, a concept, which I'm going to teach you. That is called addition through components. Right? Addition to components. So there are basic rules around about addition through components. Let me just write it down. Right? No need to waste your brain power analyzing it. Just follow the rules, because it is pretty straightforward at this point. So resolve, first rule is that resolve each okay, let me just erase this. Resolve each vector into components, right? This is the rule number one, components. Second rule is that add the x and y components separately. That means add the x and y components if there's anything that you need to ask me, just go ahead. No, don't be shy or something. So add the x and y components separately. If you want to ask me like 40 times, I will teach you 40 times. No worries about that. The main goal should be your understanding, that you should be able to understand this topic correctly, because this is quite interesting. So this is what I'm writing is just addition to component. These are just the rules. So you should memorize these rules, or basically understand them. There's no need to dive further into what do we mean by these rules and all that. So just I would say that follow these rules blindly, because there's nothing to you know waste your time at. So let's just see. Let's just move forward. So that means the resultant of two vectors, like if we are adding vectors, that means resultant of two vectors, that are Rx. You will read about more. Read more on this in the next slide. But let's just say Rx will be the sigma. That means sum of x component of all vectors, right? All vectors. And ry, again something like that, resultant. That means the total addition of all the vectors along y-axis. That means the component of the resultant along y-axis will be equal to sigma. What is sigma? Sigma is nothing but the combined sum y components of all vectors. Yep. Very straightforward. Nothing to worry about here. And magnitude will be as per Pythagoras theorem. What did Mr. Pythagoras taught us? Mr. Pythagoras taught us that magnitude will be Rx. Magnitude, that means magnitude of resultant will be Rx square plus Ry square under root. Nothing to worry about, just this. Write this down. I'm gonna give you basically 10 seconds because time is running short, and I need to explain to you one more topic before I leave. So that is pretty, we are short on time, but still, I'm gonna explain to you everything in detail. So write it down, because this is a rule book. This is a guide of how we're gonna solve addition to components. Resolve each vector into components. That means each vector can be divided into x-axis and y-axis. Add the x-axis and y-axis components separately. It's because x-axis has nothing to do with y-axis. It's like two different words. You just divide a vector into two different words. So add x-axis separately and y-axis separately. So that is what I have explained. Rx equal to sigma. Sigma is just summation. You might have seen this in class 10 statistic. Summation of all components along of vectors along x-axis, and y is y component of all vectors along y-axis. That is summation. Magnitude is through Pythagoras theorem, Rx square plus Ry square. Pretty straightforward. And let's just jump in further. Let's just jump further into the next topic, which is pretty interesting. My favorite topic actually. That is let me just yeah, that is addition of vectors. Actual addition. This is the addition to components, right? We gotta come to addition of vectors. Triangle law of vector addition. Pretty interesting topic. Just a fancy name, right? Triangle law of vector addition, as if you're gonna do something, as if they're gonna do something out of ordinary. So this is basically A, right? Okay, let me just get the pen, get the pen, get the pen. A, this is B, right? And this is A plus B. That's basically triangle law of vector addition. This is it. Like the triangle law of vector addition, such a grand name for such a small thing. So let's just see what we mean by this, right? If let's just write the definition, because definition is very important, as we all know. It comes in JEE mains and NCRT. The definition given by NCRT is held at like extreme high standard. So NCRT definition is very important if we want to pass CBSE too. That means if the vectors A and B lie along the two sides of a triangle, A and B lie along the two sides of a triangle, along the two sides of a triangle, two consecutive sides, consecutive sides of a triangle. We would then the resultant by the way, this is resultant, right? If you have not guessed it by now, this is resultant. Then the resultant is A plus B, of course, and it is represented by the third side is represented by third side. No need to waste your time on this, because this law of addition never comes into use. What is going to come into use is called parallel law of vector addition. That is the next topic. Parallel law of addition. Now this is very interesting. So when we talk about this parallel law of addition, what do we mean? Basically, if the adjacent side, if the adjacent, no, we mean that if the adjacent sides if this adjacent sides of a parallelogram, root a square plus b square plus 2ab cos theta. Yes, that is the resultant. That is the resultant. But we're gonna drive this. Thank you for answering, Aditya. We're gonna drive this. And how we gonna drive this? We're gonna drive this in this manner. So let's say like A and B represents two sides of a parallelogram. That is the parallelogram law of vector addition, right? Then the diagonal through the common vertex will be the resultant. That is A plus B. This is called resultant, right? So now let's just derive this without wasting any further time. Let's derive this. Suppose this angle is called theta, right? Then let's just extend, let's say if this is y-axis and this is x-axis, extend it further, x-axis, y-axis, right? So let's just define what A, let's find out what R is, because we need to define it. Suppose we have we translate this vector towards this side. This is B, translated, right? This is the translated version of B. So let's just drop a perpendicular. Let's just drop a perpendicular from here, because we're gonna take components of B. Now this angle will also be theta. This angle will also be theta, as this angle is theta, right? So this side will be called B. This side will be called will be termed as B sine theta through components, as we've already learned. Perpendicular side to the axis is called is vector into sine theta. Parallel side is vector into cos theta. So this is B sine theta, and this length, this okay, this this length is B cos theta, right? Just basic properties of triangle. Nothing we have done nothing until now. So we have to find A, right? Let's apply Pythagoras theorem. Apply Pythagoras theorem. Pythagoras theorem. Nothing straightforward. That means r square will be equal to this side, let's just say this side square plus this side square. Let's term this as z. Yeah, z. So oz plus zc square, r equal oz plus zc square, that is r square, right? And we know what r square is. Oz plus zc square. So what is oz? Oz will be a plus b cos theta. A plus b cos theta, right? And zc will be b sine theta. Square. Expanded, we let's just put under root over it, because it is easier for us to understand. Under root a plus b cos theta plus b sine theta. Open it. Let's just do it fast, because no need to waste time on this. A square plus b square cos square theta plus 2ab cos theta plus b square sine square theta. This is our resultant. Now take b square common. Cos square theta plus sine square theta will be equal to 1, right? This will be termed as what? A square plus b square, and we have cos square theta and plus sine square theta under in the bracket. Cos square theta plus sine square theta plus 2ab cos theta, right? This is the term which we have as r. This will be equal to 1. So what do we have here? Let me just what do we have here? We have r equal to a square plus b square plus 2ab cos theta. So what is it? We have defined z as a point. Z is a point. We have just defined z as a point. It's a point where perpendicular from C meets with x-axis. That is there. So we have r equal to a square plus b square plus 2ab cos theta. What Aditya said earlier. So now at this point, this is pretty self-explanatory. We have reached through this result. We have reached to this result through derivation. R equal to a square, a plus b cos theta plus b sine theta, or a plus b cos theta whole square plus b sine theta whole square. We opened it. We moved forward, and cos square theta plus sine square theta equals 1. This is the result. This will be the result, right? And now suppose this angle is called alpha. It is making an angle called alpha with the x-axis, right? With the vector a. Now what will be the alpha? Let me just in order to write it, let me just erase something. uh, Erase something. Yeah, what will be alpha? So let's define what tan alpha is. Tan alpha equals, what is tan alpha? ZC plus OZ, right? So that means ZC upon OZ. That is ZC upon OZ. That means B sine theta upon A plus B cos theta. Remember this result, like in your heart. Remember this. This is very important. This is a very important result. You should remember this. Basically till the day you die, because this is very important result. This will come in handy at every time when you're determining the angle between resultant and the vector A, right? So this is addition of vectors through parallelogram of law of addition. Now, let me just tell you one thing. Parallelogram law of addition is just triangle law of addition in another way. For example, let's go back to that slide. Look at this. We have BC over here. Suppose we translate BC towards here, right? Let me just write it down. See, like this is this thing. A, B, right? B, C. A, B, C, right? Suppose we translate vector towards here, towards here. We translate it towards here. So what will be the vector which is translated? Basically same thing. And if we translate A towards here, then basically the same thing. Basically the same thing. So triangle of vector addition and parallelogram law of vector addition are nothing but the same thing, but represented in a different form. And we have the proof of parallelogram law of vector addition, right? This is quite an interesting proof. So like if you read more about it, then if you do this derivation on your own, then you will be able to correctly understand what is going on. And remember, what I will teach in class, whatever I will teach in class, you should be able to reproduce it on your own. That means after this class is over, try to write down everything which I told you in separately without looking at anything from my mind. Like as if you have memorized this. I have tried this, and I got more than 250 marks in JEE mains. So I have tried this technique, and I know that this works. Uh, and this will be wonderful for you if you try to write it down everything without looking at the notes. And when you're done writing down everything, just look at the notes to see whether you have missed anything or not, because this will be quite necessary in future. As you will read about more topics in physics and in chemistry and in math, especially in chemistry, because in chemistry you need to memorize everything. If you are memorizing everything by after every class, then you would not need to memorize it before the exam. You would have everything memorized in your mind, like you would have everything at the go, like this. So this is my technique through which I got, and nearly I think uh, how much marks did I get? I got in physics. I got nearly more than 100 marks in physics. So that is the technique which I've used, and I hope you're studying. Did you, bro? Yeah, yeah. So it is an interesting ride. Uh, so I'm telling you that I qualified IIT JEE Advanced too, but the branch was not suitable. But still, the point I'm making is that please memorize these things by heart. Whatever I teach you you should be able to reproduce it on your own. I think that's it for today's class. Let's see if there's anything more. There are some examples which I had, but the time is up. Sorry. So yeah, these are the examples. If you want to do them on your own, just sorry. Okay, let me just go back. If you want to do them, if you want to do them on your own, then you can write it down by pausing the stream. So I'm gonna be ending this soon. Okay. Example two. This is example two. This is example three. Find the magnitude of uh, R, magnitude of resultant vector R of two vectors A and B is magnitude 7 and 4. If the angle is 51.3, cos is given 5 by 8. You can find sine also if you need. So these are the examples. You can try them on your own. And I also have some homework prepared for you. I hope you do that. And I think that's it for today's class. Goodbye and have a nice day. Thank you. Awesome.